Hello, my name is Ahmed. Today we will introduce to you our project, which is a simple way to automate plant irrigation, which will be useful in the field of agriculture. So mainly our project works by using inputs from two sensors, one from the moisture sensor in our soil, and this is a second sensor from a water level sensor, which is will be used in measuring the water level in the water tank. So the first sensor, the moisture sensor, is put it in the our soil, which will be then measure the moisture level in this soil and sends the output as an analog output to a digital to an analog to digital converter, which will then send it to the board to be computed. The second sensor, which is a water level sensor, reads the water level in the tank and then sends it as an analog output also to an analog to digital converter, which will convert it to digital output.
My name is Muhammad Al Mahdi and I'm working on the output part of the project. Here we have two outputs from the water level sensor and the moisture sensor. We are taking just one bit from each, which is the most significant bit. Here, this is for the water and this is for the moisture sensor. Here we have these as outputs here. In the code we handle them so they can go to the motor here and the buzzer here. When the water sensor most significant bit is 0, that means that the tank needs more water, which triggers the buzzer here, as you can see. And when the moisture sensor most significant bit is 0, that means that the soil needs more water, which triggers the motor here, as we can see. Also here we have the LCD. It has three outputs, the OK, fill tank and irrigating. OK is when the water level is good and the soil is moist. Here we need to fill the tank as the water sensor cannot sense any water. It's below the average level, so we need to fill the tank. And for the third state, it's irrigating. That's when the soil is not moist enough, and as you can see, the motor is supposed to irrigate the soil here. Thank you.
Hello and welcome everyone, my name is Ahmed Hathoud and I was assigned to the software part, the whole software part except the LCD part. We have 4 modules. The main one is the project module. We have 3 inputs and 7 outputs. We assign RW to 0. RW is read write, which when it's 0 and it's always 0 will write on the LCD. Here is the clock generator module, which generates the clock, the appropriate clock for the ADC to work perfectly. This is the clock generator module, which generates a clock that's 25 times slower than the original clock of the Altera. This is the state of the LCD. We will get to it later. and OK is the module that handles the outputs of the LCD. Here is the always block, which changes the state of the LCD, and it also changes the state of the buzzer and the bump. If the input from the water level sensor and the moisture sensor are both ones, then we are in state 0, which is OK. And if the input from the water level sensor is 0, then we are in state 1, which prints fill tank. Else we are in the state 2, which is irrigating, and the pump has 6 output pins to provide the convenient voltage, and they all work together and stop together. So if the input from the moisture sensor is 0, they all work.
Hello, my name is Islam, and I was assigned to the software part of the LCD. And this is the module for the LCD output, and it works as follows. It uses a module for generating the appropriate clock for the LCD here, which is slower 1000 times than the original clock in the Altera. And we have for every in the always block, we can handle the states and show the appropriate output on the screen. And for every state, the code works as follows. Firstly, there is a counter for every state, which tries to write the characters in order on the screen. For example, it starts by clearing. When the counter is 2, it clears the LCD. Then, when the counter is 6, it writes the first character, and when the counter is 8, it writes the second character, and so on for the other states. And the LCD updates on the positive clock edge of the enable. So the enable is 1 in every case of the counters, and then it goes to 0 at the end on every new odd clock edge. ماشي. And for every character, for every operation of the LCD, we have a variable called RS, which chooses whether we have to make a command or to use the data path. And 0 for commands like clearing the screen, and 1 for inputs, to put inputs on the screen. And then the variable LCD, which contains the code for the operation, whether it's a command or it is writing a character. And when the full text is written, a variable done, switch it 1 to stop the counter from increasing, and the code still stuck until the state changes and it goes to the other states or remains the same.